Okay, this is question 4 of the 2019 paper 2. The circle C is enclosed in the square PQRS and touches all 4 sides as shown in the diagram. The coordinates of the 3 vertices are P is 2, 3, R is 4, 17, and S is minus 4, 11. So the first thing you have to do is find the coordinates of Q. So to find the coordinates of Q, we're going to move the points by translation. We're going to move the point R, which is up there, onto the point Q. Okay, so the first step is to move S to P because that's the same movement and we want to know how much we're moving it by. So to move S onto P, minus 4 has to go forward 6 steps to land on 2, and 11 has to go back 8 steps to land on 3. So now we're going to move R to Q using the same steps. So R is 4, 17. So we're going to move the 4 plus 6 steps. We're going to move the 17 back 8 steps. And when you move the 4 plus 6 steps, it lands on 10. And when you move the 17 back 8 steps, it lands on 9. And that's it, simple as, and that's your Q, is 10, 9. Now, you need to find the coordinates of the centre of C. Well, to get the centre of C, you want to get the midpoint of either the line R to P or S to Q, because they go through the centre of the circle and the middle of those will be your centre. Okay, so first of all, I'm going to use SQ, find the midpoint of SQ. So I want to know what's the middle point between, what's the middle point between minus 4 and 10, and I have a little number line written out here and I can see the middle point is 3. And then you want to know what's the middle point between 11 and 10. So this is obviously easier to see because there's less numbers on it. So 11, 10, 9. Okay, and so your midpoint is 3, 10. So that is the midpoint of the circle. Now you can also use the formula. Okay, and I have the formula over here. So if you want to use the formula instead, the formula for the midpoint is x1 plus x2 over 2, y1 plus y2 over 2. So x1 is minus 4. That's the x from your first point. And your first point here is minus 4. So that's your x1. That goes there. And x2 is 10. So that goes there. So it's minus 4 plus 10 over 2. And then your y1, y2. y1 is 11. y2 is 9. So 11 plus 9 over 2. So minus 4 plus 10 gives you 6 over 2. 11 plus 9 gives you 20 over 2. And when you do 6 divided by 2, you get 3. And 20 divided by 2, you get 10. So you see you get the same answer no matter which way you do it. 310, 310. So whatever way you're more comfortable with, use that way. So next, part C, is find the length of the radius of C. Okay, so for the first step, get the distance from either S, Q, R, or P to the centre C. Okay, so I'm going to use from R to C. So R is 417, C is 310. So your distance then is you get your R coordinates and subtract them, and you get your Y coordinates and you subtract them and you square them. So 3 minus 4, 10 minus 17, and it's the second one you use. And 3 minus 4 gives you minus 1. 10 minus 17 gives you minus 7. When you square those, minus 1 squared becomes 1, plus minus 7 squared becomes 49. So 1 plus 49 gives you the square root of 50. So your answer is the square root of 50. Now if you want to use the formula, okay, the formula is x2 minus x1 squared plus y2 minus y1 squared. Now for this one you might want to use the formula. If you have the slope already, then it's just the top of the slope squared plus the bottom of the slope squared. So it's easy to do it that way. But if you don't have the slope, then it's probably easier to use the formula. So again, this is your x1, this is your x2, this is your y1, this is your y2. So x2 is 3 minus x1, which is 4. So 3 minus 4 to be squared, plus y2 is 10 minus y1 is 17. So 10 minus 17 to be squared. And you can see you're getting the same. It's the square root of minus 1 squared plus minus 7 squared. So it's the square root of 1 plus 49, which is the square root of 50. That is not a perfect square. If you put the square root of 50 into your calculator, you're going to get like 7.12498, 7.1 something. So don't, just leave it as the square root of 50 because that's a more accurate answer. Okay, so now find the equation of the circle C. So for this you have to use the formula for a circle, and the formula you'll get in your formula tables. And this is for a circle with centre HK. That means the centre is not 0, 0. If the centre is 0, 0, then the formula you use is x squared plus y squared equals r squared. That's with the centre 0, 0. But this, we know our C is 310, so it's not 0, 0. So you're going to use the x minus h squared plus y minus k squared equals r squared, where r is the radius. So use the centre of the circle for h and k. Okay, so your centre is 310. So h is 3, k is 10. Put the centre, 310, and the radius, the square root of 50, which we worked out up here. Put those into the formula. So the formula then is x minus, and instead of h, you have 3 to be squared, plus y minus, instead of k, you have 10 to be squared, equals the square root of 50 to be squared. Okay, so just simply put them in. And then now there's very little working out to do with this because you can't do anything with that. You just leave that alone. All you're going to resolve is this. So your answer is x minus 3 squared, just leave it. Y minus 10 squared, don't try to multiply it out, equals, and here, the square root of 50 squared, all that happens is it gets rid of the square root sign and your radius is 50. Okay, and that is how you do question 4. So this is question 5 from the 2019 paper 2. So the crescent shown in the shaded part of the diagram was created by removing a disc of 2.5 centimeters from a disc of radius 3 centimeters. Find the area and the perimeter of the crescent. Give each answer correct 2 decimal places. So let's get the area first. Okay. So first of all, find the area of the 2 circles. And you're going to use the formula pi r squared. If you're not sure of that formula, you'll find it in your tables. So I'm going to do the big circle first. So pi r squared, and r is 3. We know that from up here. It says that the big circle is 3 centimeters. So r squared is 9. So we're not going to substitute a value for pi. We're just going to leave it as it is. So put pi by 9 into your calculator, put them both in brackets. So bracket pi, bracket 9 into your calculator, and you get 28.274333888. Do not reduce this down to 2 decimal places yet. Do that at the very end or you'll get a slightly wrong answer. Now the small circle, again, we're using pi r squared. This time r is 2.5. So r squared is 6.25. So put bracket pi bracket 6.25 bracket into your calculator and you get 19.63495,408. Now you're going to subtract the small circle area from the big circle area. So your 28.2743338, write in the whole number, minus 19.63495408, subtract those, and you get 8.63937998. Now you correct 2 decimal places, and so your answer is 8.64. So the next thing we've been asked to do is to find the perimeter. So that's the area. So don't forget, I forgot, but you don't forget in your exam, put in what it is. So it's 8.64 centimeters and its area, so it's squared. Okay, don't forget to write that in because you could lose marks for not putting in those little things. So for the perimeter, step 1, find the perimeter of both circles. So the big circle, you use the formula 2 pi r. If you don't know it, it's in your tables. So in this case, r is 3. So put bracket 2 bracket, bracket pi bracket, bracket 3 bracket into your calculator, and you get 18.849555592. Again, don't round it up yet. Get the small circle, so again 2 pi r, this time r is 2.5, and you don't have to do anything to it, just straight use the 2.5. So put 2 by pi by 2.5 using brackets into your calculator, and you get 15.70796,327. Now in the previous one we subtracted one area from the others, but this time to get the perimeter of the crescent, we need to add the 2 perimeters together, because the crescent, if you look at the perimeter, it's all of the outer one and then all of the inner one. So you add the 2 perimeters together. Add the big circle into the small circle. 18.849555592, use the whole number, don't round it up yet, plus 15.70796,327, and you get 34.55751,919, and now correct 2 decimal places, and your answer is 34.56, and again, write in, this time it's just straightforward centimetres, no centimetres squared. So question 5, part B. An empty inverted cone of vertical height 12 centimetres and radius 7 centimetres is filled with water from a pipe. The water flows from the pipe at a steady rate of 0.5 litres per minute. Find the time it takes to fill the cone. Give your answer correct to the nearest second. So, step 1, get the volume of the cone using the formula, and the formula is 1/3 pi r squared h. R is 7, so r squared is 49, and the height of the cone is 12. So just put that into your formula. So bracket 1/3, bracket pi, bracket 49, bracket 12, and put that straight into your calculator, and you get 615.75621,601. So that's the first bit. And again, do not round it up yet. Okay, it says to the nearest second, so we have to work with the full number. So now that you have the volume, you want to find out how long it takes the water to fill. So for your second step, you divide your answer by the rate that the water flows from the pipe, which is 0.5, but because that's litres and this is centimetres, you have to multiply that by 1,000 to change it into centilitres. Okay, so that they're sort of in the same thing. So 615.7521601 divided by 0.5 multiplied by 1,000, and you get 1.23150432 minutes. Now that's minutes, we want it in seconds. So in order to turn it into seconds, multiply by your answer by 60 to turn it into seconds, and 1.23150432 multiplied by 60 gives you 73.89025. You want it to the nearest second, so round it up to the nearest whole number. So 73.89025 becomes 74. So your answer is 74 seconds, and that's question 5.